SpaceX rocket crashes into the moon. New crater revealed somewhere above our heads. Right now, a piece of human machinery is silently drifting through space. It was never meant to land gently, and it never got the chance to try. On August 5th, 2026, a discarded SpaceX Falcon 9 rocket stage slammed straight into the moon. There was no warning broadcast, no countdown, no cameras waiting to capture the impact live. Just silence, followed by a sudden and violent collision millions of people never even noticed. Weeks later, NASA revealed something that changed the story completely, and the internet exploded. A brand new crater, roughly 60 feet wide, now scars the lunar surface forever. NASA's Lunar Reconnaissance Orbiter captured the wound in shocking, high-resolution detail from above. Bright streaks and dark shadows spread outward from the crater like a frozen explosion. This wasn't science fiction. This wasn't a simulation. This was real debris hitting a real world. And suddenly, the question everyone started asking was simple, but deeply unsettling. How many more of these objects are silently floating toward the moon right now? To understand why this matters, we need to rewind the story a little. Rocket stages don't simply vanish after they finish their job launching satellites into orbit. Many of them get discarded, left tumbling through space with no engine, no control. For years, some of these abandoned stages have been slowly falling toward the moon. Nobody was steering them. Nobody was tracking their final destination with much urgency. They were essentially cosmic ghosts, drifting until gravity finally decided their fate. This particular Falcon 9 stage had been floating in space since a previous mission. Its fuel was gone, its purpose fulfilled, its future completely out of anyone's hands. Slowly, over months, the moon's gravity pulled it closer, inch by silent inch. And on that August morning, physics finally settled the score in dramatic fashion. The impact itself wasn't visible from Earth, hidden away on the lunar surface. No telescopes caught the flash, no satellites happened to be watching at that exact second. For weeks, the event passed by almost completely unnoticed by the public. Then, NASA's orbiter passed overhead, capturing images that revealed the full impact. The photographs showed something almost artistic in its violence, strange beauty inside destruction. A perfectly circular crater, roughly the size of a small backyard swimming pool. Radiating outward, bright rays of disturbed lunar soil stretched across the surrounding landscape. Darker streaks crossed those bright rays, evidence of deeper material thrown from beneath. Scientists immediately recognized the signature, the unmistakable fingerprint of a high-speed metal impact. This wasn't the moon's first scar from human technology, but it reignited a debate. For decades, space agencies have quietly used the moon as a convenient dumping ground. Old rocket stages, failed landers, and abandoned hardware have crashed there before. Usually, these events happened quietly, far from public attention or media coverage. This time, something felt different, and the internet reacted with surprising intensity. Maybe it was the clarity of the images, or the timing of the announcement. Maybe people are simply paying closer attention to space now than ever before. Either way, the story spread rapidly across social media within just a few days. Space enthusiasts, casual space fans, memers, and skeptics all had something to say. Some people found it genuinely alarming, calling it a warning sign for the future. If a discarded rocket stage can hit the moon, what happens near Earth's orbit? Others pointed out that space is enormous, and one crater barely scratches the surface. Still, the symbolism hit harder than the physical size of the crater itself. Humanity has now visibly, undeniably left another permanent mark on another world. This is no longer theoretical debate, no longer distant speculation about future consequences. It's happening now, documented in crisp images anyone can pull up and study. And that reality forces a much bigger, much more uncomfortable conversation to begin. Let's talk about what space junk actually means, because the term gets used loosely. Space junk refers to any human-made object left drifting without active control or purpose. Dead satellites, spent rocket boosters, and lost equipment all technically count as junk. Thousands of these objects currently orbit Earth, some tracked closely, others barely monitored. Near Earth, space agencies track debris carefully, worried about collisions with active satellites. Near the moon, tracking has historically been far less strict, far less urgent. The moon doesn't have an atmosphere, so debris doesn't simply burn up and disappear. Anything that hits the lunar surface stays there essentially forever, unchanged by weather. That permanence is part of what makes this crater so scientifically interesting to researchers. Every mark left on the moon becomes a frozen record of that exact moment. Unlike Earth, where wind, rain, and time erase evidence within decades or centuries, the moon preserves everything, turning it into a giant, undisturbed historical archive. Scientists studying this new crater aren't just cataloging damage, they're gathering valuable data. Impact craters reveal information about lunar soil composition beneath the immediate surface layer. They help researchers understand how materials behave under extreme, sudden high-speed collisions. This data could eventually support future missions, planning actual human landings nearby. NASA's Lunar Reconnaissance Orbiter has been quietly documenting the moon for many years. Its cameras are powerful enough to spot subtle changes across the entire lunar surface. When this new crater appeared, the orbiter's imaging team compared old and new photos. The difference was unmistakable, a fresh wound appearing exactly where nothing existed before. Researchers used the size and shape of the crater to estimate impact speed. Based on the debris pattern, the rocket stage likely struck at incredible velocity. Even without fuel, objects falling toward the moon reached devastating speeds from gravity alone. At those speeds, even a relatively small object can carve out a serious crater. This raises an important, often overlooked point about how the moon actually behaves. Without an atmosphere to slow objects down, everything falls faster and hits harder. There's no air resistance, no gentle drag, nothing to cushion an incoming impact. It's a brutal, unforgiving environment where physics operates without any comforting exceptions. Now, let's address the elephant in the room because people immediately started asking, is SpaceX in trouble for this? Did they break some kind of space law? The honest answer is complicated and, frankly, less dramatic than social media suggested. Currently, there is no strict international law preventing objects from hitting the moon. Space law mostly focuses on Earth's orbit, satellites, and preventing dangerous space collisions. The moon exists in something of a legal gray area regarding debris and impacts. No country owns the moon, and no single authority enforces strict debris regulations there. This incident highlights a growing gap between technology's pace and law's slower evolution. SpaceX hasn't publicly issued a detailed statement addressing this specific lunar impact event. That silence only fueled more speculation, more theories, and more viral online discussion. Some assumed it was intentional, though most experts strongly dismissed that particular idea. Realistically, this appears to be an unplanned consequence of an old abandoned rocket stage. Still, the lack of official commentary left a communication vacuum online audiences quickly filled. Comment sections turned into makeshift courtrooms debating blame, intent, and future consequences. Some defended SpaceX, arguing space exploration inherently carries unavoidable risks and side effects. Others demanded stricter oversight, arguing companies should track debris more responsibly going forward. This debate isn't really new, but this event gave it fresh, visible urgency. As more companies launch rockets, more debris inevitably ends up floating through space. SpaceX alone has launched an extraordinary number of missions over the past few years. Each mission potentially leaves behind hardware that eventually needs somewhere, anywhere to go. Historically, some of that hardware ends up burning in Earth's atmosphere, safely disappearing. Other pieces, especially those sent toward deep space missions, follow very different paths. Some drift for years before gravity finally pulls them toward the moon instead. This particular Falcon 9 stage followed exactly that slow, silent, inevitable trajectory. It's worth remembering this isn't the first rocket stage to strike the moon. In 2022, a mysterious rocket body crashed into the moon's far side too. That event sparked its own controversy, with experts debating exactly whose rocket it was. Eventually, most evidence pointed toward a Chinese rocket stage, though disputes lingered afterward. That earlier crash also created a visible double crater, fascinating scientists at the time. Researchers studied it closely, gaining insight into how mass distribution affects crater formation. This new SpaceX-linked crater adds another valuable data point to that growing research. Each impact, intentional or accidental, quietly expands our understanding of lunar surface science. There's something oddly poetic about turning space junk into scientific opportunity like this. What began as an uncontrolled, abandoned piece of hardware became a research tool. Scientists now study the crater's shape, depth, and surrounding debris pattern carefully. This information could help future missions predict risks near planned lunar landing zones. That's not a small detail, especially considering upcoming missions targeting the lunar surface. NASA's Artemis program plans to send astronauts back to the moon soon. Understanding impact risks, debris patterns, and surface stability matters more than ever now. A single unexpected object falling in the wrong location could threaten future missions. This is where the story shifts from curiosity toward genuine long-term significance. As humanity plans permanent lunar bases, debris management becomes an urgent, practical concern. You can't build habitats confidently without understanding what might fall from above. This crater, though small, becomes a real-world case study for future safety planning. Imagine astronauts living inside a lunar base sometime in the next decade. Every unexpected impact nearby becomes a genuine safety concern worth serious consideration. Engineers will need real data, not guesses, to design protective infrastructure properly. Events like this quietly contribute crucial information towards solving that exact problem. It's easy to see the story as simply another wild internet moment, but underneath the viral headlines lies a much deeper, more important conversation. Space exploration isn't just about rockets launching successfully into the sky anymore. It's also about responsibility, sustainability, and long-term thinking beyond a single mission. For decades, humanity treated space almost like an infinite, consequence-free frontier. Launch something, use it, discard it, and let physics handle the rest. That mindset worked fine when very few countries were actively launching rockets. Now, dozens of companies and nations regularly send hardware into space and beyond. The math simply doesn't work the same way it once did decades ago. More launches inevitably mean more abandoned hardware drifting somewhere through the solar system. Without better tracking, more of these objects will eventually reach the moon too. This crater might be remembered as an early warning sign, not an isolated incident. Interestingly, some experts argue this event should push for a new lunar registry, a shared international system tracking every object launched toward or near the moon. Right now, tracking exists, but it's scattered across different agencies and companies. A unified system could help prevent future confusion about origin, blame, or intent. Others argue tracking alone isn't enough, and disposal methods need real improvement too. Instead of letting stages drift uncontrolled, missions could plan controlled, intentional deorbit paths. This would prevent random impacts and allow scientists to study planned collisions instead. Ironically, controlled lunar impacts already serve valuable scientific purposes when properly documented beforehand. NASA itself has intentionally crashed spacecraft into the moon for research purposes before. The L-Cross mission famously smashed into a crater specifically searching for water ice. That controlled impact provided groundbreaking evidence supporting the presence of lunar water. The difference between that mission and this event comes down to intention entirely. One was carefully planned science. The other was an unplanned, accidental consequence. Both ended in craters, but only one served a clear, purposeful scientific mission. This contrast highlights exactly why intent and planning matter so much in space. Accidental impacts create uncertainty, while planned impacts create structured, useful scientific knowledge instead. Still, even accidental events like this one aren't entirely wasted from a research standpoint. Scientists are resourceful, extracting meaningful data from situations never designed for study. This crater's formation still teaches researchers something valuable about lunar surface behavior. Even mistakes in space exploration often end up contributing to broader scientific understanding. Let's step back and consider the bigger emotional impact this story creates. There's something unsettling about realizing our old technology can permanently scar another world. The moon has existed for billions of years, largely untouched by human interference. Now, within a few short decades, we've already left several visible marks. Apollo missions left footprints, flags, and equipment scattered across various lunar landing sites. Various countries have intentionally or accidentally added spacecraft debris over recent years. This new crater joins that growing permanent collection of human-made lunar history. Each mark tells a story, some triumphant, others accidental, all strangely significant nonetheless. It raises a genuinely fascinating philosophical question worth sitting with for a moment. What responsibility do we owe to environments we don't currently inhabit ourselves? The moon has no ecosystem, no life, no immediate consequences from human debris, yet the symbolism still matters, shaping how future generations might view space exploration. If we're careless now, while space travel remains relatively limited and expensive, what happens decades from now when lunar travel becomes dramatically more common and accessible? Will the moon eventually resemble low Earth orbit, cluttered with abandoned human hardware? This single crater invites us to imagine that much larger, more crowded future. Some readers might find this entire conversation slightly dramatic for one small crater. And to be fair, 60 feet wide isn't enormous compared to the moon's surface. The moon spans millions of square miles, making this impact statistically tiny overall. But symbolism rarely cares about statistics, and this story clearly struck an emotional nerve. Perhaps it's because space feels personal now in ways it never used to. People watch rocket launches live, follow astronauts online, and feel genuinely invested. SpaceX itself has built a massive, passionate fan base following every mission closely. When something goes slightly wrong, even accidentally, that fan base notices and reacts strongly. There's also something inherently dramatic about the moon specifically compared to other targets. It's the one celestial body most people can physically see with their own eyes. Unlike distant planets, the moon feels close, familiar, almost like a neighbor nearby. Damaging something familiar naturally feels more emotionally significant than damaging something distant and abstract. This emotional connection partly explains why the story spread so quickly online. It wasn't just a technical space news update buried in a scientific journal somewhere. It became a relatable, almost cinematic moment people could easily visualize and discuss. A rocket, silently falling for months, finally crashing into humanity's oldest cosmic companion. Let's also address skepticism some viewers might have about this entire story. Could this crater be misidentified, mistakenly attributed to the wrong object entirely? Scientists carefully cross-reference orbital tracking data before confirming an object's likely origin. While rare mistakes happen, NASA's identification process involves multiple layers of careful verification. Orbital mechanics allow researchers to calculate predicted trajectories with impressive, verifiable precision. By comparing predicted paths against observed impact locations, confidence levels become extremely high. This isn't guesswork, it's mathematics combined with detailed observational evidence from multiple sources. That's why NASA felt confident enough to publicly attribute this crater to SpaceX. Naturally, this raises questions about future transparency around similar incidents going forward. Will agencies continue publicly identifying specific companies responsible for future lunar impacts? Or will political and corporate pressures eventually push these events toward quieter reporting? Public interest, fueled by moments like this, may actually encourage continued transparency instead. Audiences clearly want to know what's happening on and around the moon. That curiosity creates accountability, pushing companies and agencies toward clearer public communication. In a strange way, viral internet attention might actually improve space industry transparency. The more people watch, the harder it becomes to quietly ignore these events. Let's shift focus slightly toward what happens next, because this story isn't finished. NASA plans continued monitoring of the crater, tracking any subtle changes over time. Researchers will likely publish detailed papers analyzing the impact's composition and formation process. This data will feed directly into ongoing lunar exploration and safety planning efforts. Meanwhile, SpaceX continues launching missions at an incredibly rapid, almost relentless pace. More rocket stages will inevitably end up drifting through space after future missions. Some will burn up safely, others may eventually follow similar paths toward the moon. Whether this incident changes SpaceX's disposal strategies remains an open, unanswered question. Other companies and countries face similar questions about their own discarded hardware too. This isn't purely a SpaceX problem. It's an industry-wide challenge worth addressing collectively. As commercial space travel expands rapidly, shared responsibility becomes increasingly important for everyone involved. No single company can solve space debris concerns entirely on their own. International cooperation may ultimately prove necessary to properly manage lunar debris long-term. Just as nations cooperate on Earth's orbital debris tracking, similar systems could emerge. The moon, once considered untouchable and distant, is quickly becoming everyone's shared responsibility. This crater might eventually be remembered as a catalyst pushing that conversation forward. Let's zoom out one final time and consider the broader human story here. We are, quite literally, in the earliest chapters of interplanetary exploration and expansion. Mistakes, accidents, and unexpected consequences are natural parts of any exploration process. What matters most is how quickly we learn, adapt, and improve moving forward. This crater isn't necessarily a disaster, but it is a meaningful wake-up call. It reminds us that space, despite feeling distant, carries very real, lasting consequences. Every object we send outward eventually goes somewhere, affecting something, someday, somehow. Ignoring that reality only delays problems that will eventually demand serious attention anyway. For now, the crater sits quietly, frozen in lunar silence, unaffected by weather. It will remain there essentially unchanged for thousands, possibly millions of years ahead. Future astronauts might even visit it someday, studying humanity's earlier mistakes up close. It could become a strange historical landmark, marking an important turning point. Perhaps future generations will look back at this moment with mixed, complicated feelings. Pride in early space achievements paired with regret over careless early mistakes. Or perhaps they'll simply see it as an inevitable, necessary step toward better systems. Either way, this crater has secured a permanent place in humanity's cosmic history. So, what should we personally take away from this entire unusual space story? Maybe it's a reminder that exploration always comes with unexpected, sometimes uncomfortable consequences. Maybe it's proof that even accidents can produce genuinely valuable scientific insight. Or maybe it's simply a fascinating glimpse into humanity's messy, ongoing relationship with space. Either way, one thing remains absolutely certain moving forward from this moment. The moon is no longer just a distant, untouched symbol floating quietly above us. It's becoming an active, evolving record of human ambition, mistakes, and progress combined. And every new crater adds another chapter to that unfolding, deeply human story, as SpaceX, NASA, and other agencies push further into deep space exploration. Moments like this will likely become more common, not less, in coming years. The real question isn't whether more impacts will happen, because they almost certainly will. The real question is whether we'll learn fast enough to manage them responsibly. Let's talk about how the online creator community specifically reacted to this story. Space YouTubers, TikTok creators, and Twitter accounts all rushed to cover the crash. Within 48 hours, dozens of videos analyzing the crater appeared across every platform. Some creators focused purely on the science, breaking down impact velocity and debris patterns. Others leaned harder into controversy, framing SpaceX as careless or irresponsible with old hardware. A smaller group treated it almost comedically, joking about humanity littering across the solar system. This range of reactions shows exactly why space content performs so well right now. The same event can be science, drama, comedy, and philosophy, depending on the framing. That flexibility is part of what makes space one of YouTube's most engaging niches. It's also worth comparing this event directly to the earlier 2022 lunar impact. That mystery rocket body sparked weeks of confusion before experts confirmed its likely origin. Investigators used telescope tracking data, orbital calculations, and elimination to narrow down suspects. Eventually, most evidence pointed toward a Chinese Long March rocket stage from years earlier. China never fully confirmed or denied responsibility, leaving some lingering uncertainty around that case. This new SpaceX-linked crater differs significantly since NASA identified it with much greater confidence. Better tracking technology, combined with SpaceX's detailed launch records, made identification considerably easier. That difference highlights how tracking technology has genuinely improved over just a few years. Faster identification means faster scientific study and faster public transparency around these events. Now let's dig deeper into what actually happens physically during a lunar impact. Without an atmosphere, incoming objects don't slow down or burn up beforehand. They strike the surface at full velocity, releasing enormous kinetic energy instantly. That energy vaporizes part of the object and surrounding lunar soil almost immediately. The explosion-like force pushes material outward, creating the crater's raised circular rim. Lighter material travels further, creating those bright rays scientists see in orbital images. Heavier material falls closer, forming darker patterns closer to the crater's center. This process happens within a fraction of a second, yet leaves permanent visible evidence. Studying these patterns helps scientists estimate impact angle, speed, and even object mass. This kind of forensic space science might sound complicated, but it's genuinely fascinating. Essentially, scientists are reading a crime scene millions of miles away from Earth. Every streak, shadow, and ridge tells part of the story leading to impact. Researchers combine these visual clues with orbital tracking data for maximum accuracy. Together, these methods create a surprisingly detailed picture of what actually happened here. It's a reminder that even destructive events can produce structured, valuable scientific knowledge. Nothing in space exploration is ever completely wasted, even accidental collisions like this one. Let's also consider how this story connects to future commercial lunar missions specifically. Several private companies now plan robotic landers targeting various lunar surface locations soon. Understanding debris risks becomes essential for planning safe, reliable landing zones going forward. If uncontrolled objects continue falling randomly, mission planners must factor that risk carefully. No company wants an expensive lander damaged by an unrelated, unexpected piece of debris. This creates growing pressure toward better tracking, prediction, and eventually controlled disposal methods. In that sense, this crater indirectly pushes the entire industry towards safer long-term practices. There's also a financial angle worth mentioning, since space missions cost enormous amounts of money. A single lander mission can cost hundreds of millions of dollars to develop. Losing that investment to random, preventable debris would be both costly and embarrassing. Insurance companies covering space missions are already watching debris trends increasingly closely. Rising debris risks could eventually affect launch costs, insurance premiums, and mission planning entirely. This turns an accidental crater into something with real measurable economic significance too. Space exploration isn't just science and adventure, it's also serious business with real stakes. Let's bring this back to something more personal and relatable for a moment. Imagine standing outside tonight, looking up at the moon shining quietly overhead. Somewhere on that familiar glowing surface sits a brand new crater nobody can see. It's invisible to the naked eye, yet permanently etched into the lunar landscape. That contrast, something so significant yet completely invisible, makes this story oddly poetic. We're changing another world in ways most people will never physically witness themselves. Only satellites, scientists, and curious internet audiences ever truly see the evidence firsthand. This invisibility might actually explain why detailed images matter so much to audiences. Without NASA's photographs, this story would have remained an obscure technical footnote. Instead, visual proof transformed a quiet accident into a widely discussed global conversation. Images have enormous power, especially when they reveal something previously unseen and unexpected. This event proves that space storytelling depends heavily on strong, compelling visual evidence. Creators who master combining accurate science with striking visuals consistently perform best. Before wrapping up, let's briefly address common questions viewers might still be wondering about. No, this impact posed no danger whatsoever to people living here on Earth. No, this wasn't intentional, despite some online theories suggesting otherwise, without solid evidence. No, this doesn't mean SpaceX broke any current international space law or treaty. Yes, this does highlight real gaps in lunar debris tracking and long-term planning. Yes, this data will likely influence future mission planning and safety considerations. And yes, more similar events will almost certainly happen again in coming years. Understanding those basic facts helps separate genuine scientific significance from online exaggeration or panic. This wasn't a catastrophe, but it wasn't meaningless either, sitting somewhere comfortably in between. It's a small, real event carrying surprisingly large implications for humanity's future in space. That balance, Small physical impact paired with large symbolic meaning defines this entire story. This single 60-foot crater might seem small against the moon's massive ancient surface, but its story reveals something much larger about our accelerating relationship with space. Every rocket we launch outward eventually writes its own small chapter somewhere in history. This time, that chapter happened to be written directly onto the moon itself. And that, more than anything else, is exactly why this story went viral. It wasn't just about a crater, a rocket, or even NASA's stunning images. It was about watching humanity's fingerprints spread further across the solar system, permanently. Before we close, let's briefly imagine where this story might lead in future years. Picture a research team, decades from now, studying this exact crater up close. They might use it as a case study, teaching future engineers about debris consequences. Students could learn from this exact event while designing safer, cleaner future missions. In that sense, this crater already has an educational legacy, even before its formal study. Mistakes, when documented properly, often become some of the most valuable teaching tools available. This accidental impact might quietly shape safer space practices for generations still to come. There's also a chance this event becomes a turning point in public space awareness. Many people never think much about what happens to rockets after their missions end. This story forced millions of casual viewers to consider that question for the first time. That shift in public awareness matters, because informed audiences tend to demand better accountability. As more people understand debris risks, pressure naturally grows for improved industry standards. Public curiosity, fueled by dramatic images, sometimes drives real change more effectively than regulation alone. This crater might end up mattering more for what it taught people than for its size. If you found this story fascinating, space exploration offers countless similar hidden stories waiting. Every mission leaves behind data, consequences, and lessons most people never hear about. Understanding these hidden details helps build a much richer, more complete picture of exploration. It's not just about triumphant launches and successful landings shown in highlight reels. It's also about debris, mistakes, uncertainty, and the messy reality behind every achievement. That fuller picture makes space exploration feel more human, more relatable, and more real. So the next time you look up at the moon on a clear night, remember it now carries a small, invisible reminder of humanity's ongoing, imperfect journey outward. A quiet crater, 60 feet wide, holding a story far bigger than its size suggests. One quiet impact, one bright new scar, and one much bigger conversation just beginning.